So back again, got coffee, sat in the kitchen, no fancy green screen, running off a couple of machines I got set up here, off a phone and the cheapest mic that money can buy. Wanted to run through a piece of software that I've been playing with, and it's a visual effect, but it's about how you feel about the world. Which is exploring slitscan video, which is an old technique. If you're not sure what it is, but you've ever seen a photocopier and thought, I wonder what would happen if I put my face on the photocopier, or you move stuff around as it comes on the photocopier and you see this scan slowly going over an image, that's essentially what slitscan does. It scans images a slice at a time. Or if you've ever seen those sort of horses crossing the finish line pictures, they are taking slices and it's manipulating time, basically. And that's the thing that I find really super exciting about it. And I've been building video slitscan stuff and exploring this using a camera to manipulate time or explore time for a long time. And I saw a couple of posts on the openFrameworks forum where people, particularly Nick Hardeman, super inspiring, thank you very much, had been posting updates for examples, and people have been piling in to add examples to the openFrameworks standard download and improving the documentation and so on. And I thought, well, I'd really like to contribute to that, but I'm coming at this from a kind of media artist, and I'm not a computer scientist, and how can I contribute? And so I put together a bunch of this code and said, well, can you pull this into the main repository? And a couple of people were very kind and complimentary and said, yeah, fine. I tied that up with documentation, and this is exploring a piece of code that's actually in the examples folder that you can download with openFrameworks for Mac and Windows and Linux right now in the video examples. And this is exploring how to make a simple slitscan clock and manipulate the video. So without further ado, let's just smash into it. If you download the nightly distribution for Mac or Windows or Linux of openFrameworks, in the examples folder, there's a whole bunch of fantastic examples contributed by really, really clever people. And then in the video is a recent addition that I put in called slitscan radial clock example. And you'll get pictures in there of what it looks like when we're using this radial slitscan. And you can see it's taking images and distorting them in a circular fashion. And then there's a simple README that walks through some of the examples. But I'm going to dive through the code and show you what it's doing. The first thing that we're going to do is I'm going to compile it so you can see what the hell I'm talking about. So if I hit the compile button, it's taking feed from the video camera. It's grabbing the video camera. And if I get rid and go to desktop, we're grabbing the video camera. We're recording slices of the image, a piece at a time, and then we're twisting them in a circular fashion, and we're also showing people what the time is. Coffee. And as we go round, the full circle takes 1 minute and then starts it again. As you can see, it's the whole view of wherever the camera is pointing at, moving from rectilinear to polar coordinates. I think that's the correct way to talk about it, basically making it circular. And we can operate this in a couple of different styles. One is this scanning the whole image, and this next one is just taking the center slit. And anything that moves past the very center of the camera gets recorded. And if it stays still, it doesn't get recorded. So if I move out of the way, let me come back to the camera, the desktop here. If you look at what's going on with the video, this is pushing from the center, and anything that doesn't move just stays exactly the same color, scanning from the middle of the picture. But if we move through, that center line, you'll see it gets recorded. And again, on this, a whole circle takes 1 minute. So by pressing the 1 key or the 2 key, we either record the whole width of the camera, but 1 second at a time. You can see this progressing in seconds as it ticks around. So we take the whole picture, and one end of the picture is 1 minute older than the other end as we're taking tiny slices. Or we take the middle of the camera and we just push it sideways like a ribbon. And then we twist it radially. And if I hit the R key, we'll unwrap this and you can see exactly what's going on, where we scan across the whole image, ticking away. Probably on the audio you can hear the clock ticking away behind. And each slice is going for 1 second. And as it comes, you'll see one end of the picture is 1 minute older than the other. Or let it walk past the clock and you'll see it updating. If I go to the other style, we're taking the exact center of the camera, and every second we just duplicate those pictures out, those pixels out like a ribbon, sliding it from one side to the other, which means if I move out of the way slightly, all of the stuff behind the Polish forestry sign full of shotgun holes and so on stays and turns into a stripe, but anything that moves through the center of the camera gets recorded. And if I want, I can also debug, and you can see my picture-in-picture. If I move to desktop only, you can see the picture-in-picture and so on. So I'm going to come back, stop this, and I'll walk through what the code is doing. There's comments all the way through, so hopefully they'll make some sense. In our header file, we're going to set up a couple of things. We're only using a few routines. So we have a setup, an update, a draw pressed routine, a key pressed routine, and then one other function that I've added in called calculate time, because we need to work out how to write the time in a human sensible way from getting the system time just to display it on screen. If you don't want to display it on screen, it doesn't matter. We make an OF video grabber called video grabber, and we set up some buffers to stick images in as we're slicing them up and manipulating them. So we've got a pixels object called video pixels and another one called pixels, and a video texture object, a bunch of integers. Most of these are associated with actually making the clock count. So seconds, minute, hours, number of seconds, number of minutes, number of hours. A couple of booleans to say, are we drawing this in a radial fashion? That's B radial. And are we debugging? And then the current time, the width and the height. And I'm using, to get this typeface bigger, rather than using the standard OF bitmap text, I'm using a TrueType font, which I've got loaded into the data folder. If I come to the example, in the data folder here, you see we've got this folder Liberation Mono. And you could put in any typeface you like. Here's a TrueType font. And we load that in, which means that we can just draw a nice font onto the screen. So in the main, at the top here, I've put in a bunch of different relatively standard sizes that your video camera may grab at, depending upon what kind of camera you've got plugged in. So I'm grabbing at 1280 720, which is common for an Apple HD webcam, which I've got plugged in here, but you can get any other camera you like plugged in. So you could take this out into the fields or anything else you'd like, and you can also grab at smaller sizes and bigger sizes and so on. So if you're having problems setting up your camera, it might be either you're detecting the wrong device because you have to tell it what device is plugged in that you want to read from, or you're trying to grab at a size that your camera doesn't understand how to talk. I set up a couple of integers just to explain that there's 60 seconds in a minute, 60 minutes in an hour, and 24 hours in a day, of course going from 0 to 59. And then if we want to start the clock in different styles, we can do. I'm starting as scan style 2, which is this ticking across the whole screen. But as you see, we can press buttons 1 or 2 on the keyboard and they will get red, and we try different styles of slitscan. We load up a TrueType font at quite a large size. This 100 is the size of the text. And then we take a relatively standard piece which comes from the video grabber example of please go through and find all of the devices using video grabber object list devices. List me out all the devices that you can find attached, and then use log notice to print them out. And if I come down here in the debug, if I can find this, we should have from the last time it ran. Here we go. This section here, where it's printed out, device 0 is the FaceTime camera, device 1 is OBS virtual camera, because I'm using OBS Studio in here, and you can install a virtual camera so that the feed from OBS turns into something you can chuck through Zoom or whatever. So we want to use this device 0, which is the HD camera. But if you can't work out where your camera is, come and you'll see in the debug which one you want to use. So then we set up the video grabber and we set it to use device 0 here. Let me make the text a little bit bigger again. So we want device 0, we set up a standard frame rate, and then we tell it to grab at the width and height that we'd set up above. And then we say that we want to allocate our video pixel buffer to be the same width and height as the camera and to be RGB pixels. And what we can then do is do the same to allocate the video texture we made to be the same size as video pixels. So we've set up our camera and then we've made these buffers of pixels and textures to be the same size. We switch off the background, and then I call this routine calculate time, this function that I'd written, and all that does is it goes through and says get the system time, get the milliseconds and so on, convert that into like a 24-hour clock kind of thing. So if we scroll down to the bottom, you'll see I just put this calculate time, and it's probably completely the wrong way to do it and it's brute force, but it works. So I'm saying please make a string, and because the clock hours will give us 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2, etc. If it's below 10, I actually want to pad it with a 0 at the beginning, so always the readout, the printout of the clock is the same length. So if it's 9:30 a.m., it'll say 09:30 a.m., so that it's the same width as if it's 12:52 p.m., it'll be the same width. So we say if the hours is less than 10, pad it with a 0 at the beginning of the string. If the minutes is less than 10, pad it with a 0 at the beginning of the string. If the seconds is less than 10, pad it with a 0 at the beginning of the string, and then concatenate these, the hours, the minutes, and the seconds, into a new string with a colon between each. So we're saying take the string clock hours, add a colon to it, add minutes to it, add a colon to it, add seconds to it, and put it into this string time that we can then just print straight out to the screen. So I'm going to scroll right up to the top again. And in our update function, the first thing that we want to do is call video grabber update. And that just says to the camera, please go off and refresh yourself, so if there's a new frame available, we can pull it in. And then I can use the video grabber object, and it's got this function called isFrameNew. If it hasn't found a new frame after we've updated it, there's no point pulling it in. But if there is, we say get the pixels, which is this array of color, pixel array, and put it into our pixel object called pixels. And because of how it comes in, we want to then say pixels mirror. And we can mirror it in horizontal and vertical. And so we flip it so that it's round the other way. Just flip it. And then I want to know, because we're doing this ticking, we could just go run as fast as you can across the screen. But I really want one side of the screen to the other to take 1 minute. So it's a clock. And divide that screen into 60 slices and then say tick, 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 tick. The computer that I'm running on is much capable of running much faster, but I'm saying if 1 minute has elapsed, and I'm using this by saying get the current system minutes, compare it to a variable where we're sticking the last system minutes in there, and get the minutes and update it. And the same with the hours. And then I push calculate time again. And update what we're doing with the timing. Now, then I do the updating of our video images. And there's two styles. And this is a horizontal push, which we saw streaming everything sideways, which we're calling a ribbon. And I'm saying that get where we are, and I'm keeping where we are, scanning across the screen in this variable x steps, and I'm saying get the width of the camera and divide it by the number of seconds. So we take the width of the screen, or the width of the camera, divide that into 60, and we count across. And then I'm going to go through all of the pixels on a vertical line. So I'm going to go from Y to the height of the camera. So I'm going to count down in the Y direction. I'm going to say grab the color of the pixel at that point, which is the Y height, and halfway across. So I'm saying when we start the loop, Y is 0, and then it goes down to the height of the camera. I'm saying go to the middle of the screen, grab the pixel there, give me the color. And then go through the loop again, grab the pixel at the next position down, and then go through the loop and grab the pixel at the next position down, and so on, all the way down to the bottom of the image from the camera. And then I do it again, shuffling everything across one. So I'm then going to grab the color that's coming from the image from the camera, which is in pixels. So it's this full screen image. And I'm going to set the color at position 1 in the X and all the way down in the Y in the video pixels image. So I'm grabbing the color from the camera, putting it into our pixels image, pixel buffer, and then I'm taking a slice of that and putting it at the very first edge of video pixels. And then I'm gonna take everything and shuffle that across one pixel. So I always write to the first edge of the image, but every loop I'll shuffle the image across one pixel and then write to the first edge, shuffle it across. So we end up with this ribbon. So we do basically the same thing again, but across the width, and I just shuffle every pixel across one pixel. So the next frame I can write down this edge and it just streams whatever's changing. And then I load, because I can't draw pixels directly to the screen, I take the data from our pixels, load it into our video texture, update where we are going across the screen, and end that loop. And then I would draw it. Now, if I press button 2, it'll do a different kind of routine, which it progressively grabs pixels from the camera going across the screen, tick, 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 tick. So I end up with a complete picture from the camera, but one end is a minute older than the other. So we do a very similar thing, but instead of sticking in the same place where we're grabbing the pixels from, we move where we're grabbing the pixels from as we go across. So Again, we're looping through the camera width divided by the number of seconds. So divide our camera into 60. And again, we're looping through vertically down all the pixels in the camera height. And we're saying grab the color, but instead of from the center, we use this, where we go, how far across the image are we in our steps of 60 seconds? Take the camera width, divide by the number of seconds, and then multiply it by seconds. So we're going to go across a bunch of steps at 0 seconds, or the middle will be 30 seconds or 45 seconds over here, and grab me this little set of pixels. And then we do exactly the same to grab the pixels from the camera and put it into our video pixels image, or video pixels data buffer. And then when we're finished, we transfer that into the video texture, and it's ready to draw. And the simplest thing that we can do is we just say, get the video texture and draw it starting at position 0, 0, and the width and the height. And then after that, we use font that we loaded our TrueType font into to draw string of shapes. So it'll go over the top of the video and be masked properly. The string time, where we'd assemble the hours and the minutes and the seconds, at a position on the screen. And that gives us our image just running straight across. And if I run this again, we'll see that working. So it starts as example 2. So it's doing this tick, tick, tick from one side of the screen to the other. If I switch the radial off by pressing the R key, you'll see starting 0 seconds, it grabs the whole screen, and it grabs a slice, moves across, grabs another slice, grabs another slice, grabs another slice, and this the wider the camera image, the more resolution that will have. And if I press 1, it'll do this. It's grabbing just from the center of the camera, drawing it to one edge of our video buffer image, and then shuffling everything across. So anything that's moving through the middle of the camera, we get the change in pixels. And if I move out of the way, anything that's not moving, we don't see it. So far, so good. But how do we make it go circular? It's a little bit brute force. We're not doing anything clever. We're not actually making a circular image. We're manipulating the screen as we draw slices of our image. So if I come to the draw routine, I'm saying if the Boolean radial, when I press the R key, it just toggles the radial on and off, true and false. If it's true, we're going to draw a radial image. So the first thing we do is we get the width of the video texture, and we loop through every line on the width. And I'm going to use push matrix and pop matrix to be able to manipulate the screen. And the first thing I do is I push matrix, which freezes the screen, and I can translate it. When I pop matrix, it'll come back to where it was. I translate the width and the height at the middle of the screen. So now the middle of the screen is actually 0.00 rather than the top left. And then I rotate the screen using a mapping function, which gives us an input and then a defined output, so it does all the scaling for us. And I'm saying, get the width of our video texture image, and irrespective of how wide that is, give me an output that's between 0 and 360. So it'll say, get the width, and then just scale it to be an output of 360. And then what I can do is I can just rotate by 1 degree and draw whatever is in that video image at that point. And that gives me my circular thing. So we slide across to the middle, and then I just rotate the screen and draw. So the draw routine doesn't know what's going on. I've just rotated the screen that I'm drawing on. Then when I unpop the matrix, it just pushes it back. And then all I've got at the end is minus 180, so that it starts drawing at the top rather than at the side. And then I use draw subsection which means I can get a piece of an image and just draw that out of it. So I get the video texture, draw subsection, and part of the height, and then pop matrix, and then it loops it again and again and again. So I'm continually drawing a tiny piece and rotating the screen round, and that gives me my circular image, irrespective of what's in the video texture. So it could be a live video if I wanted it to be, but it either be this ribbon that's been pushed or this ticking slit scan. And then at the bottom, I just said, if the Boolean debug is true, draw me the output of the camera straight to the screen so I can see what's going on, and draw me a bit of debug text telling me the frames per second. And then down here, I've got a switch statement in the key press to say, toggle the full screen. If I press 1, make a horizontal ribbon. If I press 2, make a slit scan clock and the debug. And then down at the bottom, I'll calculate time. So I run it, and there we go. Big, fat, slit scan, clock. And if I move this to desktop only, you'll see ticking away down there in the bottom of the seconds. And if I put my debug text, you'll just about still be able to see me up here. And there we go. A great big slit scan example. And you can download this now. It's in the nightly builds of openFrameworks. I'll be doing loads more with slitscan stuff because I really like this. I've been going to be exploring some stuff with video, and I'm going to walk you through probably an iOS application that we've got. There's a coffee machine. Coffee. It's such a really cool sound. I might put some echo on that or something. So that's slitscan clocks. That's openFrameworks example. Coding from the kitchen. Why not? I'll see you on another video. Thanks for watching. Bye.